So for solving exponential equations, we need to write these in the same base. So we have 9 and we have 27. So what base is 9 made of, and what base is 27 also made of?
3.
So 3 to the second power makes 9, and that 9 is raised to the 2x. 27 is 3 to the third power, and it's raised to the x minus 1. So we're starting to convert it over to the same base. When you raise a power to the power, we can multiply exponents. So we have 3 to the 4x, and we would need to distribute. That's going to be the trick here. We've got to say 3 to the 3x minus 3. Now we have the bases the same. When the bases are the same, we can set the exponents to each other. So minus 3x, minus 3x. So x equals negative 3. We can test that answer using a calculator. We can say 9 to the power of 2 times negative 3. Not exactly what I was expecting, but 27 raised to the power of to the negative 3 minus 1. And you see that we get the exact same decimal value when we plug our value back in. So it's a great way to check it. Here we have 64 and 16. Using a power chart, you could look to see which column has the 64 and 16 in it. 2 can be represented, but also 4. So 4 to the third power is 64, and 4 to the second power is 16. So we'll multiply our exponents. So 4 to the 3x equals 4 to the 2x plus 2. You got to be sure you distribute it to both. Now what would we do from this point? Making decisions. When the bases are the same, we can set the exponents equal to each other. And now we just solve it like any algebra problem. So we get x equals 2. The trickiest part is trying to get the bases the same. So to what power can we use? Or what base are we going to use to set these? 4 could work, even 2 could work. It doesn't matter which one you use. But 4 is going to make you have to simplify it less. So 4 to the x power, nothing's happening there. Now to get 1 over 16, we know that 4 squared is 16, and if we put a negative in front of that, that puts the 16 into the denominator. So 4 to the negative 2 is 1 over 16. And that's to the x plus 3. So we have to distribute that, and we set our x equal to negative 2x minus 6. We can add our 2x across and divide by 3. For case number 2, we have a different situation. Here, of course, we would need to add the 7 to the other side. We have 6 to the x power equals 27. And we have to make a determination, can we make the bases the same? In this case, we can't. 27 can be made of 3 to the 3rd power, but 6 is not made by repeatedly multiplying an integer. So, reading our notes, if unable to rewrite in case 1, and if we're unable to write it with common bases, we need to isolate the power, then we're going to rewrite the exponential equation in logarithmic form, because we need to solve for an exponent. And we all know that the logarithm equals the exponent. So log base 6 of 27 equals x. So here we would need to use the change of base formula. Log of 27 over log of 6. So we can type it into our calculator. It's very important that you close the parentheses around the 27, because we're going to follow that up by dividing by log of 6. And that's our 1.84 if we're rounding to the nearest hundredth. So we need to show our steps. In the next one, we can't make our bases the same. 7 and 15 don't have the same base. But we can use a logarithm with the base of your exponential of 15 equals your exponent. A logarithm always equals the exponent. So we would use log of 15 over log of 7. Change a base formula. Our calculator can easily do the common log. So the common log of 15 divided by the common log of 7 gives us 1.39. Now don't forget, you can use alpha y equals, go over to the window menu, which is function, and you can choose logarithm base, which is number 5. You could use this and type in your 7 and type in your 15, and you'll get the same exact decimal. But the work to be shown should be this change of base formula. You need to do something to show your work, not just jump from one part into another. Go through your work. We divide by 9. And we get 0.15. 0.15 is an approximated answer, of course. If we use the real answer here, and we plug that into 7 raised to the 9 times our x value, use the real answer, you're going to get exactly 15. Here's one with E. So 4 e to the negative 2x equals 17. If we divide both sides by 4, Now we've isolated our base with its exponent, so we need to turn this into a logarithm. Now when the base is in e, we don't typically write log. This is where we use ln. ln automatically has the base of e. A logarithm is going to equal the exponent, and it's the logarithm of 17 to the fourth power, or 17 divided by 4. So we do the natural log of 17 divided by 4. That gives us 1.44. We can round that if we like to 1.45. Divided by 2. Divided by a negative 2 gives us negative 0.72. So x is approximately negative 0.72. So now it's your turn. Pause the video, try it out, come back and check it out. Here we have 9. It's made of 3 squared. 3 squared is to the x, the 2x power. We're going to have to multiply there to get 3 to the 4x. Then we can set our exponents equal to each other. We can move over the x if we wish. And divide. And that clearly comes out to be 1. Here we have log base 5 of 72 equals x. So we write our change of base formula, which always puts the base into the denominator. If you like to use the alpha y equals to go over to the log base option, you're welcome to do that. Base of 5 and 72. Or you can just say log of 72, close the parenthesis, divided by log of 5, and you're going to get the same exact decimal. Doesn't matter which method you use. You should show your work in this format. So x is approximately 2.66. Here we would need to move our constant numbers over first. Then divide. You want to isolate your base. Now to get into the exponent, to be able to solve for the exponent, we need to use a logarithm. This logarithm is going to have the base of our exponential, a base of e. So that's going to be the natural log. It automatically has a base of e. A logarithm always equals the exponent. So it's the natural log of 1. Interesting. And the natural log of 1 we all know is 0. So we divide by 0.5, and x has to be 0. And if we don't trust that, we can come down and try to plug that in. So 3 e to the 0.5 times 0. So what's that going to do? That's going to make 0, and e, any number to the 0 power is 1. So 1 times 3 is 3 plus 2. This is actually going to work. And you get 5. If you ever need to check your answers, you're able to do that. if a calculator is available. Let's try that. All right. We have two more problems to work through, or we're solving for an exponent, and then we have some practice ones on bottom. We'll do the best we can to get through these. Newton's law of cooling has this crazy equation where T of O is the original or the initial temperature, T of R is the room temperature, the surrounding temperature. The R value is given to us, and we're going to be solving for T, for how long does it take. So we have a T value that we want to get to. We want to get the temperature to become 30 degrees. We have hot chocolate. It's heated to 90 degrees. So the original temperature is 90 degrees. It's placed on a table with a surrounding temperature of 20 degrees. So now what we need to do is solve for the T. We got our equation, we need to solve for T. So you just start undoing this. So we subtract the 20 over 90 minus 20 is 70, e to the negative 0.145 t. We would divide by the 70. We could cross the zeros out, and we have 1/7. So 1/7 equals e to the negative 0.145 t. We have isolated the exponential. We've isolated the base. So now we need to get to this exponent. So that's going to be the natural log with a base of e equals the exponent of 1/7. So using our calculator, natural log of 1 divided by 7, it's a little dark, is going to come out to be negative 1.95. Negative 1.95. We'll divide by the negative 0.415, and we get this 13.42. So 13.42, these would be minutes. T is measured in minutes. So crazy formula, but we're still just solving for the value of t, solving for an exponent. We're going to need to use a logarithm. Here we know that we're depositing 500 into an account that pays 2.1%. Compounded quarterly, so we're going to have to divide that by 4. So that's going to be 4 to the t power. So when is this going to turn into $1,000? So we would first divide by 500. That, of course, equals 2. We have our 1 plus 0.021 divided by 4. That gives us our decimal version, 1.00525. We'll keep it as exact as we can. Now we have the exponential isolated. So we're going to solve for the exponent. To solve for an exponent, we need to use a logarithm. The logarithm needs the same base. The logarithm always equals the exponent. So we'll need to use log of 2 over log of 1.00525. Log of 2, close the parenthesis, divided by log of 1.0025. So that's going to give us 4t equals 277. And divide our number by 4, 6940. All right, the rest of these are practice ones. Feel free to go through and work those out. I'll pause the video. I'll work through those. I'll display the answers, but won't have a walkthrough of every question.